My name is John Pontrello, and welcome to Class 1 of How Music Works. Today we're going to be talking about the alphabet of melody. This is going to lay the foundation for all of the future classes. This is an 8-week course, and this is just Class 1. So, really excited to talk about this subject. I've been teaching music for over 10 years, usually focused just on one instrument at a time. Sometimes I have students that want to learn more, but this is really, for me, the essence of everything that I teach. This information that I'm teaching is very useful. It can be used in so many ways. It can help you learn multiple instruments. That's kind of the beginning of this for me. Is I started out, just playing the drums, and then from there I've learned so many different instruments, and this. How music works is how I was able to do that. It's also great for playing music with other people to be able to communicate musical ideas. This is a great class for a drummer who they know a lot about rhythm, but maybe not as much about harmony or melody. This can help give them a language for that. It's also great if you want to be writing music, composing music, whether you want to go in the direction of writing it on a staff or just even making beats, composing music using in a computer using a DAW, a digital audio workstation. So whatever it is that you want to do in music, I feel like this is just kind of like the baseline information. So we're just going to dive right in here. So kind of the way that I think of music is it is composed of these three fundamental ideas of rhythm, melody, and harmony. So rhythm is really all about how we organize sound in time and how we synchronize melody and harmony. It kind of serves as the pulse of music, and then there's just so much you can do with rhythm. Basically, if you can make something into like a rhythmic pattern, it starts to sound like music right away, no matter what that sound is. So the next one is melody, and this is how notes are organized in time. It's like the tune of a song. If you're going to be playing a note and then the note that you put after it, you string those all together, that's going to create a melody. And this is in contrast to harmony. Harmony is about when you play notes simultaneously. It's how you combine sounds at the same time that creates harmony. So I kind of think of all of these three things working together to make music. And depending where you're coming from, what instrument you play, what your specialty is, you might have knowledge of specialized knowledge of about melody or harmony or rhythm. But really the goal of this class is to develop a well-rounded understanding of them and how they all relate. So that's what we're going to be working towards. So before we dive into to the alphabet of melody, which is the focus of today, I want to basically give a little bit of information about sound, how sound works, and because sound is the main ingredient that we use in music. So not all sound is music, but all music is made of sound. So we're going to be talking about sound. So sound comes in waves. Anytime you hear a sound, this is a musical sound, a harp. There are waves happening in the air. We cannot see them, but that is what is producing the sound. A better metaphor for a sound wave is to think about if you're standing on a bridge and you got a big rock and you drop it in the water. And then from where that rock goes into the water, it makes waves going everywhere and, going outwards in a circle. And that is exactly what happens with sound. Every form of sound, it's like a wave of energy traveling through the air. So these sound waves, this is really important to understand if you're going to understand how music works and how we come up with different tones in music. So how we measure sound waves is through what is called a hertz. And a hertz, really, it just means vibrations per second. So right here, you can see when the wave goes up once, goes up and goes down, when that happens once in 1 second, it's called 1 hertz, okay? And it's 1 vibration per second. Now, if we were to, in that same second, have 2 cycles of that wave, it would be called 2 hertz. So it's this, basically, hertz is a measurement of frequency. So this is a signal generator, and when I press with my mouse, it is going to play a frequency measured in hertz, and it's going to show the wave as well. And I want to mention before I do this that this is a the visualizer for the wave is basically a microscope of the wave. It only shows about 1/10 of a second as opposed to 1 second, because most musical tones are in the hundreds of waves per second, and it would be very difficult to see that, especially since it goes all the way up to 1,000. It'd be very hard to see that. So that's why the way that we're able to see this is microscopic, showing about 1/10 of a second. So, all right, let's click on this and see what happens. All right, so that was 394 hertz. That's 394 vibrations per second, and that's what it sounded like. As I go lower in tone, you can see the distance between the waves they're getting farther apart. There are less waves in 1 second. If I go up high, once I get up to about 2,000 there, it starts to get really high, high frequency sound. So right now we are able to see the waveform, see it as a number, and then also hear it. So basically, I'm playing with the frequency by going up and down. Now, it's kind of an XY thing. So when I go up and down, it creates, it changes the pitch, or it changes the frequency. When I go left to right, it changes the amplitude. And the amplitude is basically how big the wave is or how small the wave is. That's like, when you threw that rock off the bridge into the water, was it a big rock creating a big wave and a big sound? Or was it just a little pebble and creating a little small wave and a little sound? So when I go to left to right, you can see the wave getting smaller and notice that it gets quieter. So when I move left to right, you notice the wave getting smaller and the sound getting quieter. Now if I move it to the other side, the amplitude is growing, the waveform is getting bigger. So when I move it the other way, the amplitude is growing, the wave is getting bigger, and the sound is getting louder, okay? So this is a lot of fun to play with. So this is a lot of fun to play with, and I want to show you an electronic instrument that is basically just a signal generator that you play with your hands. And it's called the Theremin. So similar to what we were just doing with our mouse, this Theremin, it's the craziest thing. You put your hands in the air, and where you move your hands changes the signal that's being generated. So basically, when you move your hand horizontally across this way, horizontally, it changes the frequency. And so physically, we're talking about frequency, but then when it converts to sound, it becomes what we know as musical pitch, okay? Now, same thing when we go up and down, vertically, going up and down, it changes the amplitude, which we hear as the volume of the sound. So by using one hand, we change the frequency and the pitch, and by moving side to side and going up and down, we change the amplitude and the volume. So I want to show you an example of a master playing this amazing musical instrument. Her name is Clara Rockmore, and she is performing the Swan on the theremin. It's absolutely amazing. I want to show you another way that we can learn about this instrument. So this Google Doodle was created on Clara Rockmore's 105th birthday. So wherever I move my mouse determines the tone that's being created, and if I go up and down, it makes it louder and quieter. Up is loud, like going lower is quiet. And so that's affecting the amplitude or the volume. And then if we go left or right, this is changing the pitch. This is changing the frequency. So I want you to notice one of the things about this instrument is one of the unique thing about this instrument, and you might have noticed in the other video, is the way her hand trembles. Okay? What's happening here is when her hand is trembling, she is creating kind of like a quiver in the sound, and it kind of brings the sound to life. So the name for when you quiver a sound with amplitude and volume, that's called a tremolo. So it's like it's trembling. Her hand is trembling, the amplitude and the volume is trembling, and it just gives it that feeling of that it's the sound is not just this static electronic tone, because that would sound very, it would make it sound like it's a piece of test equipment. But the way that she moves with it is what really brings this instrument to life. And then the other one is vibrato. And this is usually a term people use to describe in singing. And what it is that the frequency or the pitch is kind of trembling or quivering, or, it's slightly going up and down. And so that's something that happens with this instrument, the theremin. So what exactly is a musical instrument? What separates just an ordinary object from a musical instrument? Basically, the way that I think about it is anything that you can get different pitches from qualifies as a musical instrument. If you have two pieces of wood and one's big and one's small, and you can get them both to vibrate, it's basically a musical instrument. If you have a string that you can hit, and then you make it tighter and you hit it and it makes a different sound, that's also a musical instrument. Or by shortening a string, or if you're blowing air through a column and you can affect how long that air is traveling, that will also create differences in pitch. So these are just some of the common ways that musical instruments are made, so that we can get all these different tones out of them. But the theremin, which sounds like it's an instrument from the future, was actually created just over 100 years ago. And it was it's basically just a signal generator. It just made sounds, but then they realized, figured out ways that they could control that sound, and then that's how it became an instrument. So there are instruments all around us all the time. So I want to show you an object that is also a musical instrument that you might not have thought of before. So this is a demonstration of a musical saw, and some people compare this to the theremin. So you can see the way he kind of moves his hand, he's kind of doing this just a little bit, which vibrates the whole saw. Okay, so this is a piece of metal that is vibrating as the bow goes across it. And this is just as much a musical instrument as the theremin. So here we have another sound generator, and when we play it, there is 261.626 of a frequency. And so that is the frequency number. Now, this is something we haven't talked about yet, but we started out with a sound wave, a visual sound wave, and then we looked at how that was turned into a frequency, how many vibrations are happening in a second. But musicians have then converted this into letters. And this serves a couple different purposes. One is that, you don't want to turn to your friend and say, hey, can you play 261.626 hertz? It's just very impractical. The letters help us organize this in a little bit of a simpler way without having to think of math. You can just say, hey, play a C note. It's a lot easier. But it's still based on math, so that's why we're still looking at this connection. Okay, so right now we're on C4, okay? So if there's a C4, there's got to be a C5, right? And how do we get there, okay? So basically, when we're talking about pitch, we're talking about letters, and there's only 7 letters, A, B, C, D, E, F, G, and then it starts over at A. But right now, we're actually starting at C. And so when it repeats, then we add a number to it. And so it goes C, D. So I'm going to actually take you through it. So we're at C4. There we're at D, E, F, G, A, B. And look, we're back at C5, okay? Now we could keep on going, and basically when we go between different Cs, this is called an octave, okay? It's because it's the 8th note. Octave, oct means 8. So there's 7 letters, A, B, C, D, E, F, G, but the next one, when it repeats, is called an octave. Now, if you don't understand this word octave, it's kind of an abstract word, but I think if you just try to follow along, I think you'll eventually get what I'm talking about. So I'm gonna round this number 260. Oops, that was too high. So we're just going to call 260C for right now. It's close enough. Now, this is where it gets interesting from a mathematical perspective, okay? So we're on C4 260. So if I double this, 260 plus 260 is 520. Now I'm at C5, okay? So by doubling the frequency, we get an octave. Okay, I'm going to double it again, so 1040. It's getting pretty high there. Now we're at C6. C6. If I double it again, 2080. That almost hurts my ear, right? So let's go back. So if we divide it, it's the same thing. So 140, 520, 260, and we could keep on going lower to 130. Even lower. Okay, so this just shows us how octaves work, and we're going to look at some other fractions, but right now we're just multiplying it by 2 or dividing it in half. So right here shows all of those frequencies. So let's say that 130 is our fundamental tone, and that's the one that everything is based off of. So so that's just 1-to-1 ratio. Okay. Now if we go 2-to-1, then we get 260, and that brings us to an octave of that fundamental tone. So we were on C3 for the fundamental tone of 130, but now we are on 260, which is like the first octave based on 130. Now, if we keep on multiplying this in half, if we keep on multiplying this by 2, we grow exponentially. Okay, so we went from 130 to 260 which is the first octave, to 520, the second octave, 1040 to the third octave, 2080 to the fourth octave, and you can just see it keeps on growing exponentially until, look, we get up to that 8th octave and it is 33,280. So that is actually outside the range of human hearing. We couldn't even hear that note. The range of human hearing is 20 to 20,000 hertz. Okay, but if you've ever seen a dog whistle, it's something that you blow on. You cannot hear it, but dogs react to it, and that is because their range of hearing is much higher than ours. So let's take a look at this on the piano. So here is a C note. We're just going to call this our fundamental tone. And I'm going to go up an octave. There's my next C. Even though we can't see it, we can hear it. Very low frequency, right? Let's bring it back to where we can see. Okay, so we can play these octave notes, and this teaches us about music. But what we are concerned about to come up with that alphabet of melody is, what are the notes in between? Now, how I think about this is the octaves are kind of, it's like a building and they're floors, okay? So it's like your fundamental tone is your ground floor, okay? And let's say this is our ground floor, right? Or let's say this is our ground floor. Now this is our ground floor. Now we're gonna go and take the stairs up. We're on the first floor, okay? There's 7 steps. All right, now we're on the next floor, the second floor. Each floor has 7 steps to get to the next floor. Now, we know that there is, we used math to figure out the octaves, okay, to figure out where the next floor is. But there's also a mathematical equation to figure out these notes, where the steps come from, these steps of the major scale. And that's what we're going to look at next. So let's put it on 130 here. All right. Now, when I hit next, it's going to divide all the notes in between 130 and 260 into musical steps. Okay, so the root is 1 to 1, and then the octave is 2 to 1. And then all of the notes in between have their own fraction, basically, their own ratio, which creates the interval, the distance away from the root note, the fundamental tone. So now we've just taken that note and put it in a circle, and this is kind of cool. It helps us to play them. So each one of these notes has a ratio away from the root note. And this is actually where we're getting introduced to the alphabet of melody, what I like to call the alphabet of melody. By giving them words, just like in the phonetic language of the letters, that different letters tell us what to do with our mouth. the alphabet of melody tells us what to do with tone. And this is actually called solfege. The do, re, mi is called solfege syllables. Okay, so do is the root note, it's the first note. Re is the second note. Re. Mi is the third note. Fa is the fourth note. Sol. La. They call it C, I call it T. Tomato, tomato. And then we got the octave there. So I have a friend that I made, an animated friend, that's going to help us understand this a little bit better. Octave the octopus. So you can see, the reason I call them octave is because it helps us remember that there's 8 notes, there's 7 notes and the 8th note repeats. So it's do, the original do, the root is 1-to-1 ratio, and then the octave is 2-to-1. And then all of the notes in between have different ratios. You can see them on here, and we're going to look at this a little bit more in depth with a keyboard. Okay, so do, our 1-to-1 ratio is the fundamental tone, and it is C. Okay, if you have a piano keyboard, you can try this out. We'll demonstrate this on the piano in just a second. But for right now, I just want you to understand. So our fundamental tone is 130, and because it's 1-to-1, we multiply it by 1. So that's how we get our fundamental tone. Okay, so for our octave, the ratio is 2-to-1, and that equals 2. So we're going to multiply 130 by 2, and that gives us the octave, which is 260 hertz. So the next ratio is 3/2. This is the next simplest one. So that's why the order that we're going in is from simple to complex. So the first one was 1-to-1. That's for the root. The octave is 2-to-1. And then now we're looking at the perfect fifth, and it's 3-to-2. Okay? So 3-to-2 equals 1.5. So we took 130 hertz, multiplied it by 1.5, and came up with 195 hertz. So that's how we get the G note. Okay, the next most simple is 4-to-3, and this is the interval for the perfect fourth. Okay, so that means we take 130 hertz, multiply it by 1.33, and we come up with 173.32 hertz for F. Okay, now keep in mind C is actually not 130. I rounded it just to keep it simple, otherwise we would have way too many decimal points. Okay, so we've got 4-to-3. The next most simple fraction is 5-to-4. Okay, now 5 divided by 4 equals 1.25, so we're going to take 130 hertz, multiply it by 1.25, and we're going to get 162.5 hertz, and this is the major third, and that's the letter E. Okay, now the next this is a little bit more complex. 5 divided by 3 equals 1.667. This is La. This is the 6th scale degree, the 6th note in the scale, the major 6th. So we took 130, multiplied it by 1.667, and came up with 216.667. So that's how we came up with A. Okay, so Re is 9 divided by 8. That equals 1.125. So we're going to multiply 130 by 1.125 and come up with 146.25. And last but not least is T, the 7th note, and it's 15 divided by 8, and that equals 1.875. So we take 130, multiply it by 1.875 to come up with 243.75 hertz. All right, so you can see it kind of creates that staircase that I was talking about, slowly going up intervals in between the ratio of 1-to-1 and 2-to-1. So there you have it, the solfege syllables. This is the relative system of that creates the major scale in what I like to call the alphabet of melody. Now keep in mind, pitch on its own is just pitch, but really what makes it musical is the way it relates to other notes. So when we play these notes together, it sounds musical. And that's why I call this the alphabet of melody. If we were just choosing random pitches, I would not call it the alphabet of melody because they would not create basically a harmonious relationship between notes. So you know, obviously there's some interpretation. This can be subjective, but just for learning the basic idea, I think this is kind of the easiest way to do it. Most music that you hear is already made with the major scale, so that's kind of why I like to start there. And then from there, we're going to actually start looking at variations on this major scale as we get further down the road in this course. So now we have a lot more context to understand these notes working together, that they come from ratios and fractions, and that these notes are not just randomly chosen, but they're basically all of these fractions that are derivative of a root note. Okay, so keep in mind your root note could be anything, and then so you could move do to start on any frequency, and so and then the notes that are in relationship to that root note we have given names. Okay, do, re, mi, fa, sol, la, ti, do, and that's why I like to use that, especially for melody. We'll talk a little bit more about the numbers in the future, but for melody, the do, re, mi is really nice. It helps you learn the tones. It's kind of like a phonetic language in the same way we use letters. The English language is phonetic. We use letters to tell our mouth to make different sounds. The do, re, mi is a tonal language. So do, and it's all about the relationship between the notes of the do, re, mi. That's what really determines it. So let me just show you an example of a song here. So mi, re, do, re, mi, re, re, mi, sol, sol, mi, re, do, re, mi, re, mi, do. It's one of the simplest melodies there is. Okay, so just one more thing I want to add here for fun is the rainbow. So you'll notice the Chrome Music Lab, the shared piano, and the Songmaker, they use the same notes, the colors, as the rainbow. And I just think that's really cool. I always like to draw a parallel between sound and light because they are both governed by the physical universe that we all inhabit, and they are all made of waves. So I just think that's really cool and something to think about. So now that we have all this information, we been messing around with it on the piano. I want to show you another way to write music, also known as automating music or sequencing music, using the Songmaker app in Chrome Music Lab. So this is the Songmaker app, and basically how it works is we can place notes anywhere we want on here. When we go higher along the horizontal plane, it goes higher in tone, higher in frequency, higher in pitch. When we go left to right, it plays the notes in time. So when I press play, it's going to move from left to right, and as the timing passes over the note, it's going to play it. So let's hear what happens. Not really musical. Let's try to play around with this. Oops. Going to press the restart button at the top here. So let's actually just start out building the scale here. Oops. Do, re, mi, fa, sol, la, ti, do. So right there, just going up, each one of these squares takes us up a scale degree, okay? Now you'll notice going from left to right, this is the timing. So you'll notice there's like shaded box versus non-shaded boxes. These are measures of music, and this goes into rhythm. I'm not going to go super into it, but I just want to show you that right here, 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8. Okay, so there's 8 time slots where we can put a note. These are called eighth notes. Okay, because there's 8 of them in a measure. But what we want to kind of be dealing with, the most simple one to deal with is, we're not going to use both of these slots. We're just going to use one of them. So these are called quarter notes because there's 4 of them in a measure. So if you just use to the left of the line, like where the thicker line is, that's the quarter note. So 1, 2, 3, 4, and then it starts over. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So there's we got 4 measures, 4 notes each. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Pretty cool, right? All right. So let's actually use this to make a song, okay? Let's start. We just did the song, what was it? Let's just start out with the song that we already did. Mi, re, do, re, mi, re, re, re. Then there's a rest. Mi, sol, sol. I need to go in settings, and then I need to add, we're at 4 bars, 4 measures. I'm going to add 8 so we can finish the whole song. So, mi, re, do, re, mi, leave a blank spot, re, re, mi, re, do. I think that should be it. Let's find out. Do, re, mi, re, 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 mi, sol, sol, mi, re, do, re, mi, re, re, mi, re, do. There you have it. So you can see I can change the sounds down here, and then I can also put like little drum sounds. Let's change it. Let's see what this one is. Oops. There's blocks, drum kit, congas. Let's just go through this whole thing. And then look, I can even change the tempo. I can slow it down or I can speed it up, okay? We'll talk more about that. Let's make it faster. So it's kind of interesting. We got this tempo thing here, and it tells us, it gives us a number. Now that number corresponds to beats per minute. Okay, so earlier when we were talking about frequency, we're talking about basically waves per second. Okay, I kind of think about I think there's a parallel here between rhythm and pitch and frequency, right? So if we have 60 beats per minute, that's kind of a slow rhythm. That is 1 hertz, right? Because a hertz is 1 per second. So a more common tempo is like 120 or so. I can't even get it. It's 121. So if we have 120 beats per minute, how many hertz is that? 2. It's 2 hertz. But we cannot, but if that's a wave, like a vibrating string or like an actual frequency, we can't hear it because it's so slow. It's so slow that we actually hear it more like a rhythm. So this is just an example of how, melody and harmony and rhythm, they all kind of combine in interesting ways once you start kind of thinking outside the box a little bit. But this is something we're going to explore as this course develops. Let's do another song. Okay, this next song, Twinkle Twinkle Little Star. Do, do, sol, sol, la, la, sol. Fa, fa, mi, re, re, do. Sol, sol, fa, fa, mi, re. Sol, sol, fa, fa, mi, re. Oh, we need to go and add some more. So let's go into the settings here. I'm going to add, let's make this up to 12. I think that's how many this has. Okay. Do, do, sol, sol, oops, sol, la, la, sol. Fa, fa, mi, oops. Re, re, do. Okay, let's hear how this sounds. Fa, fa, mi, re, re, do. Sol, sol, fa, fa, mi, re. Sol, sol, fa, fa, mi, re. Do, do, sol, sol, la, la, sol. Forgot to put a rhythm. Uh-oh. Oh man, I messed up there. I messed up there at the end. You can see that, right? There we go. Now I got to move everything. So it's frustrating when you get one messed up because then you got to change everything. I think that's right. Let's hear again. Okay, I got something wrong. There should only be one note there, right here. So I took that one out because it's like da, 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 and then there's a rest. Okay, so that's one of the hard things about automating music is figuring out where the rests are. And that, I mean, there's a lot of challenging things. One of the other challenging things is figuring out where the first note is. Because if you don't have the first note right, then you might get to a point where you want a note, but it's not in the scale. So if you're playing a song, you're trying to play a song that you have to know which the first one is. And honestly, there's the only way to really learn that is by getting it wrong. When you get it wrong, you got to try another one. You got to experiment. And that's why they call this Google experiments. This in music, that's, it's a lot about experimenting, getting the wrong notes. But as it becomes more a part of you, that you don't get as many wrong notes. You kind of refine your ability. But even no matter how good you get, you still can make mistakes in the process. But really, this is all just about the process. So you have some tools now to create your own melodies using the alphabet of melody. You can write your own melodies. You can do songs that you're familiar with. You can look at a song, kind of have an understanding of what notes are used in it. So I have made a handful of songs with recordings that you can listen to and try to figure out the melody. In fact, I have actually done the first part of it just to get you going, and then I've left like about halfway through the song, I've left that blank. So that's your homework, to try and finish the song. All right. Thanks for joining me in class 1 of how music works. The next one is going to be about intervals, the building blocks of chords. So hope you can join me. All right. We'll see you soon. Goodbye.